This is starting chapter 6.1, Properties of Exponents, part 1. So we know that if we have 4 to the third, that means 4 times 4 times 4. And just a regular number means that it is to the first power. So the exponent means how many times that number is being multiplied by itself. If we don't have one, it's an invisible little one. If we have a zero exponent, for any non-zero number, a, the power of a to the 0 is 1. 0 to the 0 power is undefined. So 3 to the 0 power is 1. 1/2 to the 0 power is 1. And negative 12 to the 0 power is 1. It doesn't matter what this number is. Whatever is raised to that 0 power, the answer is 1. If I have negative of 12 to the 0 power, that's like negative 1 times 12 to the 0. Negative 1 times 1 is negative 1. Now if I have a negative exponent for any integer, so any number n, and any non-zero number a, so if I have the negative exponent on the number, it is the reciprocal, so that means you flip the fraction of a to the positive exponent. So if I had negative n here, this is the same as 1 over a to the n. If the negative is in the bottom, I flip it so it's in the top. That's all you do. The negative just means it moves that term, that number, bottom or top, to the opposite place of where it started, where the negative is. And then it becomes positive once it's flipped. So 4 to the negative 2 is 1 over 4 to the positive 2. That's important that we no longer have negative exponents. And then I can simplify that. I know 4 squared is 16, so this would be the same. Now we're going to evaluate these. That means we're going to get a number answer. So for 9.3 to the 0 power, anything to the 0 power is 1. 3 to the negative 4th power, that's 1 over 3 to the positive 4th, that's 1 over 3 times 3 times 3 times 3. 3 times 3 is 9, and then I have another 9. 9 times 9 is 81. I'm going to simplify 6x to the 0 power over y to the negative 7th. First thing, I don't want this negative, so I'm going to take it and move it into the numerator. So then I get 6x to the 0 power y to the 7th. I know x to the 0 power is 1, so 6 times 1 times y to the 7th, that's just 6y to the 7th. And we have two more. 3 to the negative 2nd power, x to the 4th. I'm going to take the negative exponent and move it to the bottom. So this one's positive, it's going to stay here. So this is 1 over 3 squared times x to the 4th. Now when I multiply fractions, straight across the top, straight across the bottom. I don't have the denominator written here. I know it's 1. So this is 1 over 3 times 3. And so this would be 1/9 times x to the 4th. And then you have x to the 4th over 9 is the simplified answer. Here for 3 to the negative 2nd power times x to the negative 5th, both of these have negatives. So both move to the denominator, and now they are positive. And then I can simplify 3 squared to get 9. So my answer is 1 over 9 times x to the 5th. Let's look at just a couple more. If I have 5 to the negative 7th power, x to the 3rd over y to the negative 4th, this 5 to the negative 7th is going to move to the denominator, and the y to the negative 4th will move to the numerator. Now I can write them out as 3 different fractions, and that just helps me keep track of everything to know where they should be, to make sure that I am being clear and know what is negative, what is positive, where does it belong in the fraction. And now I can multiply straight across the top, straight across the bottom, and then I can simplify 5 to the 7th, which is 78,125. And here I have 3 to the 4th power, x to the negative 6th, y squared, over z to the negative 8th. So I'm going to move the x to the denominator and move the z to the numerator. So x is on the bottom now, z is on the top, and I can simplify 3 to the 4th is 81. And I can't do anything with the y, z's, and x's because they are all different numbers, all different letters. I don't know if they represent the same number, but since they are different variables, it's safe to assume that they are not the same number. So since they are different variables, they just stay separate like that.